Wyrick, and today I'm going to be explaining thermoelectrics and Peltier's. The thermoelectric effect is a conversion of temperature differences to electrical voltage and vice versa. The Peltier effect is the presence of heating or cooling at an electrified junction of two different conductors. When voltage is applied to it, it pumps heat from one side to the other, so one side will get hot and one side will get cold. This is the diagram of an inside of a Peltier. Peltier is made out of two different types of semiconductors, positive and negative, and these semiconductors are arranged like a checkerboard inside. On the top and bottom of each of these semiconductors is an electrical conductor made usually out of copper. On the outside of all these are two ceramic plates used as heat insulators. When this is hooked up to an electrical source, one side will get hot and one side will get cold. This is a temperature conditioner that I engineered using a Peltier. We have the Peltier inside here between this piece of insulation and a water block. This water pump pulls water from this reservoir through a radiator, which is attached to two fans, cooling down the water before it flows through this water block. The water block pulls the heat away from the hot side of the Peltier and flows it back into the reservoir, where the process is repeated again. This is done to pull all the heat from the hot side of the Peltier, getting the cold side as cold as we can get it. This is our power source. In here we have the fans and the Peltier wired to the same port, and we have the pump wired by itself. The data in this graph was recorded while I was running tests on the Peltier being used in my temperature conditioner. The graph displays the temperature difference between the cold and the hot side of the Peltier. The values on the bottom of the graph are the temperature differences, and the blue lines are showing the rising amount of voltage being run into the Peltier. The highest temperature difference that I recorded was 69 degrees Fahrenheit, with almost 10 volts of electricity being pumped through it. That is an amazing temperature difference for a device with less than 5 millimeters of space between the cold and hot side. The data in this graph is a perfect example of a Peltier at work. Look at the frost on the penny. That penny is attached to the cold side of the Peltier, which we have clocked in at about -8 degrees Fahrenheit. The all-time low I calculated for the cold side of the Peltier was -14 degrees, the average being -10 degrees. The most common uses of Peltier thermoelectric heat pumps are in homemade desktop PCs and in temperature conditioners like the one that I engineered. Thank you for watching my video, and I hope you consider me for the scholarship.